Hi there, welcome to this video on how to write an operator for Kubernetes. We're going to look at how we put together a simple Golang based operator through a controller and then apply the behavior on top of it to make it an actual operator that's representative of human behavior. So let's dive right in and take a look at what we're talking about. So typically speaking, what makes an operator is that it has an additional layer of logic that can perform activities based on certain inputs and outputs from a desired resource that's being watched. So we would be watching a resource, and this resource would be in the cluster. This might be something like a config map, it might be a pod, or it might be a custom resource that you've defined in the cluster and the operator can also see. The operator would typically then look at the Kubernetes API, and that API would allow the operator to have updates and to write back changes. Now, the difference here between an operator and just a controller is that we're going to have an additional layer of effectively logic that can operate depending on the situation, right? So it's not simply CRUD management of does this exist, if not create that resource. We can create some additional types of logic that can be dependent on certain conditions. So when we think about how to actually build this, well, luckily for us we have a few tools at our disposal. There are a few SDKs. We have Operator SDK, we have KubeBuilder SDK, and there are a few others out there that all have a similar kind of methodology in that they produce a batteries included solution. The key components that a lot of these end up using is a framework called controller-runtime. Controller-runtime is a popular project as it packages together a lot of things you need to create fairly simple reconciliation loops within your code. Controller-runtime also goes hand in hand with Client Go. Client Go is the Kubernetes client for Golang that will talk to the API server on your behalf. It has a lot of utilities inside of it, such as creating new configurations for your Kubernetes client and for managing the sessions within. That said, another part that the SDKs offer us, a little outside the scope for today, but that is using GoGen to generate our custom resource definitions. So we can create a file and then run a GoGen command on that file to enable us to do deep copy and even create client sets that are easier ways to work with these resources. And a client set I like to think of as effectively a primitive batteries included method for your CRD. So client sets are equally important. They also give us configuration, and that configuration is in the form of YAML. So they will give us the deployment YAML for a controller, and they will then allow us to simply regenerate that deployment when it changes. So that said, the question might be, well, why are you going to try and show us a video of replacing not only a controller, but the behavior on top of that controller to make it more of an operator? Well, I feel personally that you learn a lot more about this if you actually have first-hand experience of what are these things doing under the hood. So really what we'll be focusing on today is Client Go. So Client Go, you can see, is the library here that I'm putting in the bottom of the stack. But actually it's one of the most fundamental, because once you can talk to the API server, you can do more or less everything else yourself. We're going to leverage another really important library, and that is the mechanism, or the interface I should say, for how we do watching of these resources within the Kubernetes API. We have a few different interface types available to us. Going from lowest level to highest level, we have watch, we have informer, we have shared informer, and then we have shared index informer. Effectively what these are different client-facing exposed interfaces for updating from the Client Go library, from the API machinery library, that gives us an interface to understand when changes are coming back from the Kubernetes API. So if you imagine it like this, you set up your watcher, and that watcher is to subscribe to a particular type of resource. That could be this one here, which might be a config map or a pod. And then when you're ready, that watcher will give you back some updates for that resource. So the watch is the lowest level implementation. Watch gives you back the event stream in the form of a channel with the event type. Informer is a slightly more structured approach in that it gives you back function bindings. So it returns to you a struct interface, and you have to bind, update, create, delete functions in which you will then do something else. Shared index informer and shared informer, both of these will share the API server connection and the resources between those, whereas shared index informer will actually allow for a level of caching and pagination for huge amounts of data. So there are different use cases for each of these, but today we'll be focusing on client Go, and we'll be using the watch implementation, because when you're trying to write your own controller and your own operator, the watch interface is extremely powerful because we can really control how the implementation looks. And you might have often wondered, when you're using something like Operator SDK, how does it manage everything inside of a single reconciliation loop? Well, we can implement that ourselves. So with all that said, there's an example project that'll be included in this video with all the code required, but I'd like to walk through what the code base needs to contain, and we can do this in pictographic form. So let's have a look at what we actually need inside of it. Well, fundamentally, we need to have a Kubernetes connection. So we start with our config map, kubeconfig, connection to API server. Some nice to haves like exposing Prometheus metrics, so expose Go metrics. And if you might have noticed on the left of my screen, I have this project open already. We also might want to have a convenience method for opening things like our kubeconfig. And I mentioned earlier that client Go can manage your kubeconfig. Just to be a bit more precise, it's actually client command, which is the package that will allow you to import an existing kubeconfig, build a kubeconfig, use in-cluster config, etc. So I'll put kubeconfig plus loading. So we've got connection to the API server. We then want to be able to watch our resource. After we've watched our resource, we want a way of interacting. So ability to interact with resource under certain conditions. And this is the crux of what we'll probably be building today, is that ability to interact with the resource and the ability to scale that out so we can monitor different resources and build more of a repeatable pattern than a one-time slingshot item. So if you look on the left hand of my screen, you'll see that I have a simple project. As I mentioned, this is the CN Skunkworks operator, which I'll include in the video. It effectively is a single main.go and a go.mod. The go.mod is relatively straightforward. All you really need in here is client Go. I've also introduced klog for Kubernetes logging. I can change that out. And in fact, I may well want to use logrus or something else later on. And I've got the Prometheus client Go. As I mentioned, it's nice to have Golang metrics. So all I'm doing is in the init function or in the main.go is I'm just exposing an HTTP handler with the default Prometheus handler. So we can get some basic instrumentation in. And that's important to me because I believe that in any project, you should be putting observability in as a first-class citizen. What we have at the bottom here is probably the most complicated part of the project, in honesty. The most complicated part I personally find in building any kind of operator or controller is usually pinning the Go mod correctly. So to show you how I've done it here, every single cates.io library that I use is pinned to the same version. And that's extremely important so that when we're doing upgrades of this library or this project in the future to another Kates version, it's done seamlessly and we're not running on multiple different versions. Equally, if you didn't have a replacement file, what you would find is that there are many conflicts between, for example, controller-runtime 0.09 and the client Go implementation. This is usually due to transitive dependencies being on different versions. So that said, you can look at this in the project. You can see how I've pinned this. I've got a few other ones as well. These aren't required right now, but they were from a prior project. So for example, Gnostic and OpenShift API and controller-runtime aren't used yet, but I've added this in for when later in the video I do use them, you'll see that they're pinned already to a version. So let's look through the main.go. First things first, variable declaration. You've got the basics, kubeconfig, master URL, address, timeout, and watch timeout. And these will come in handy a little bit more when we start talking about how we're going to implement the watches. At the top of the file, we have our klog init. We're then passing these flags. The flags.pass is an interesting one because that's actually called in the main, but the init function, as you'll probably be familiar if you're a Golang engineer, it gets called first. So the initialization is happening. It's defining the flags to watch for. It's then passing those flags. So when it hits this point on line 50, we'll have our flags already been read if they exist. A few other things that have been added just for utility are start time. That's really not necessary, so I'm going to take that out. And I've got this little Go routine here that creates on another in another routine the Prometheus metrics handler. The most interesting part for us as we start to get into the nuts and bolts of this is we're using client command. The first thing it's doing is trying to get the kubeconfig from a URL. If that URL is empty, it will not be able to build the kubeconfig. We can look at what happens if that is the case, and we can build an in-cluster config. There are a lot of options on this library for building different types of configuration, and in fact, what you find here is that the fallback is that it will be an in-cluster config. So as I've clicked through there, you can see that the return will be using an in-cluster config. So if your master URL is empty, it will go under the assumption that you're actually running this inside a pod, which is great because it means there's less work for us. And then the final part here is we have a client set imported. We're not doing anything with it yet, but that's a good place to start this next segment. At this point in time, I wanted to take a few moments just to give an idea of my setup. So I'm actually running this through WSL. It's using VS Code. It's fairly idiosyncratic, I would say, in that WSL is not the fastest thing for running these libraries dynamically. As you'll see, when I start debugging, there's a little bit of an overhead time on initialization, and that, from my perspective, puts a little bit of a strain on doing this in a live video. So what I would tend to recommend is, if you're using WSL, is probably switching to something like Golang, as it's a lot faster when you run it natively rather than through a WSL client. In addition to that, I'm using a simple kind cluster underneath this, but that could be Minikube, that could be a real Kubernetes cluster hosted in a cloud environment. So what you'll see here is, this is not really doing anything, it's taking a bit of time. So what I would prefer to do is I'm going to grab this project, I'll close it, and I will, on my screen here, which you probably won't be able to see, is I'm going to open up Golang, and I'm going to put it up right where VS Code was, and what that will do is that will be using the native Windows IDE. As you can see, it's more or less the same thing. I'll just make sure I've pasted in the right bits and pieces. We also need to make sure that it's visible and legible so that you can read it and see what's going on. The only major difference here is that because I'm running kind in WSL, I will need to import the kubeconfig so that I can hit it from the Windows client. So let's go through and make sure that this is all set up. And I think this is always quite nice to see in videos because sometimes they're a bit too sanitized, and I always quite enjoy watching people set stuff up. So first thing I want to do is make sure this is actually easily legible. So I'm going to just go into the settings, increase the editor font to 20, just to give folks a little bit more view into that. Also, this is a slightly different config. So I'm just going to load in the config that I was showing on the screen a moment ago. And this will all be, as I mentioned, in the repository at the end. So that's the config I was using. And this is because I was starting this project in WSL, and I've migrated since to using native Windows client for build speed. So let's synchronize these dependencies that are missing, and we should be pretty good to go. You can see here it's downloading protobuf, it's downloading everything I'm missing. The Golang client is great. I really so the Golang IDE is great. I really can't fault it. I've never had any problems with it, and it's fantastic on prediction, and it's also extremely snappy on identifying any issues. It is a paid-for client IDE by JetBrains, but if you are considering paying for one, I think this is a really good proposition. Alternatively, they also do, I believe, an open source license. So if you're a maintainer or an owner of an open source project, I believe you can apply for free permissions to use Golang. Okay, so we can see everything's working. The only error is I've got here is that it says no Kubeconfig's been provided. So what I've done is, in my setup for this project, is I've given it a flag and told it to use my kubeconfig. At least that was what I thought I'd done. There you go. You can see there, kubeconfig equals kubeconfig. So I'm just going to go ahead and grab that kubeconfig. So kind export kubeconfig, and that will print it. In fact, that should print it out. It's not going to. So what I'll do is I'll just copy that kubeconfig from my kubeconfig directory. I'm then going to put it into mount, C, users, Alex, I think it's Golang projects, C and skunkworks operator, kubeconfig. So now we've got a kubeconfig that should be copied into this directory. You can see it there. Now when I run this again, what should happen this time is that it sees this file, it loads it in as a flag, and nothing much really happens. So let's have a little look. No kubeconfig's been set. Not a problem. Let's just switch the build configuration and see if that solves it. In fact, what I can do is, I believe the build configuration I have was right. I just need to edit the program arguments. Let's have a look. Okay. So there we go. Very unceremonious, but we have the first phase of our operator. We have a connection to the Kube API, and you know, it's a small win, but it's important. So let's mark that. So step 1, connect to Kube API. We've done that. So the next thing we want to do is to get some value out of this, and this is to sort of start building the code segment out. So okay, let's think about how do we actually watch a resource. Well, we need to get the client set. So we're going to call this the default Kubernetes client set. It's a bit wordy, but for this video I want to be really clear on what stuff does. So with the default client set, let's get now something like pods, and we can watch all namespaces. And now we've got this great new method called watch. So I've gone default client set, core v1, package, pods of all namespaces, watch. And you can see that takes context, and it takes options, meta, list options. So let's put in a very short-term context here. So we'll put a to-do in. We might want to have a context with cancellation function later on. And we'll put a meta v1.listops in here. And the nice thing usually about Golang that I quite like is it will do a lot of the imports for you. But if it doesn't, and you find yourself in this situation, all you need to do is to click through to the watch command. You see the meta v1 listops. That package will be defined at the top of this file. So it's right there. I'll need to include the same package, which comes from apimachinery. That also goes in the top here. And now I have my watch. So what does the watch actually do? If we look at the return type, it returns an interface and an error. So that interface is a structure with channels inside of it. So we're going to call it yface, and if error is not equal to nil, well, at this point in the program, it's so critical that the watch works, we'd probably put it as a fatal, right? So we'll say watch interface, and we'll set the error on that interface, and that will exit out. So let's have a look at what yface actually has inside of it. It has a results channel and it has a stop. So we have the ability to pull messages from the results channel, and we have to also recognize when a stop command has been called. In fact, this is something that's useful in that we can call it. You can see here it doesn't actually have a return type. Stop is something that you can call on the channel. So let's have a look at doing a naive implementation of how we would monitor a channel. So we want to put it in a loop because we want to get a bunch of updates constantly, and then we need to use select, right? So we've got to select on what we want to do. So let's select with the cases. We're going to say new message. So our message is going to come from the yface.results channel, And at this point in time, I'm not too picky about what happens. We're just going to try and print it out. So let's go klog info message dot let's say event type. Okay, and that's pretty much it to get started. So let's get that going. So I press debug. What's happening now is in my Kubernetes API, any resource of the type pod is going to be updated. Now you can see on the left here I've got a little error. That's because I've not included this package. So let's just go off and grab that package. Often you'll see this kind of problem where you try and click to it on the IDE, it gives you grief about it. So what you can do is just run it through the terminal directly. So I'm actually not even going to run the version pin. I'm going to just download it. Okay, let's try that again. So we go back to debug. You can see it's compiling now, and lo and behold, we see added. Doesn't mean a lot though, right? At this point in time, we just got added. So tell you what we could do. Let's cancel this, and let's do a log info, info f, and we'll go percentile plus v message. Let's have a little look at that message and see what's going on there. And again, this is just using a vanilla kind cluster. So if I go back to here and I ls, now I think I've got kubecontrol installed in Windows. No, I don't. But I'll open it in my YSL client, WSL, just to show you there's not really much going on in this cluster. All namespaces. You can see that's all I've got running in this cluster. And equally, when we look down here, we can see that this should match 1-to-1, right? So kubeproxy, even down to the UID of the pod running. And remember, we're printing objects here, so these are quite large. These are runtime objects, so they're serializable, and we can cast them to a concrete type when we need to operate on them. And that's a big part of what we'll talk about next, because how do you make the operator useful, right? And how do you actually take it beyond just a dumb controller that is just reading a loop? Well, that's where we need to start thinking about a little bit of what's the logic required to do something interesting. And how would this look, right? So I have a results channel. Do I want to keep that in my main? Does this results channel just pipe everything? Or do I want to have a results channel per type? So at the moment, let's just consider this. So we have a watch interface for a single resource type, and this requires a loop. So effectively, maybe we're starting to think, a sync and wait group might be a better way of running multiple concurrent watches, right? Because if you have an operator that has to deal with a couple of different resources, then that could be a better way of doing it. Equally, we're not really handling anything right yet. So I'm going to go ahead and just start to make this a slightly more sophisticated implementation. So let's create a package called package. We'll create a Go file in here. Inside of package, in fact, just for the sake of keeping things clean, let's create a new directory and call it runtime. In the runtime, we'll create a runtime.go. And I find this quite a nice methodology because you're splitting the main.go from the runtime loop. And the main.go becomes the initialization file, right? That's where you manage your telemetry startup. That's where you manage a lot of your factories, and the runtime becomes a separation of concerns and keeps things simple. And so the runtime doesn't need to actually even be a struct, it can just be a function. So we can call it run loop, right? Something really simple. Runtime.runLoop, and we'll pop this in there, and we're going to call runtime.runLoop. Now, of course, there's a bunch of stuff we've got to pass in, and then we've got to ask ourselves, is this a very simple implementation, right? Because really, we probably want to pass in the watch.interface as an array, because we want to pass in the things that we care about. But then at that point, you've got to ask yourself, how do I then express what the watch interface does, right? We have two things we care about, right? We need the watch interface. What do we do with it? What do we do with the stuff from that interface? And then one way we could perhaps express this would be in a new struct. So we could say type, in fact, it could be, we could have an interface for it. Firstly, we could call it, watch struct or pod watcher, and then that would have inside of it the watch interface. So that'd be watch.interface, and then what we could do is we could bind it so that we have an implementation, like a reconcile implementation. So it could take a function that things would pass into. So we could say something like reconcile, and reconcile could be a function, and that function might take the types that were inside of our runtime.go. So in the results channel, we had, I think, event.type. So you can call it object, so that'd be runtime.object, and then event type would be, I think it was event.type, but I've got that wrong. So already we're starting to make some decisions about how to structure the program in a way that makes a bit more sense for being able to have discrete logic. And this is nice because it creates a bit of reusability. So let's do that. So we've got runtime. Let's also just define what the internal operator watch interface looks like. So I guess we would create subscriptions. In fact, to be pedantic, I guess I call it subscription, singular rather than a plural. And then in here we could have a new file called iSubscription. I think for me personally, this is a throwover from working with Java and C# and other languages that like to let you know when there's an interface. So let's say we've got now our type iSubscription interface. Okay, great. That iSubscription interface, as discussed, is going to have a watch interface. That's watch.interface. And that's giving me an error. I also think that probably needs to be public. I'm not sure yet where I want to share it, but I'll put the watch.interface in there. I'm going to grab the watch command that I had. Now it's gone from here because I've moved. In fact, I haven't moved it. It's here. The watch interface is defined in this file here under apimachinery package watch. There's a lot of moving parts at the moment, which is why I'm getting some errors, so I'll just comment that out. So let's go back to our interface definition. Oh, it's fascinating. That's escaped it for me, which I don't need. Okay, so let's have a look. What's the matter here? Why is it complaining? Unused import. Okay, so let's have a look what's going on. Oh, of course. This is an interface, and you cannot define types on an interface. We just want to define effectively our methods that we will call on the interface. So this is again why we have to think things through. So let's think about that. What would the subscription have? The subscription would have a reconcile loop, I suppose. So you'd have reconcile, and at this point is where you could have object, runtime.object, and then I think it was event type. Let's just double check what that was, what we got from the main.go. So watch returns the watch interface, and on the watch interface you get channel event, and channel event returns event type. Okay. So that is also part of the same library. So that would be event watch.event type. Cool, which is effectively a string. So that's kind of what our subscription interface is going to look like. And that subscription interface is going to be important because it's going to be how we actually connect what we want to watch to the code that's going to operate on it. And I guess there's another thing we need to do, and we've got this generic reconcile function, but there also needs to be the ability to convert the reconciliation into a specific object for that subscription. But we'll come back to that a little later. So that said, why is this important? And what else do we need to do? Well, let's think about the subscription interface as it is at the moment and what we need to do to make that useful. So if I was to go to runtime and say that we have a bunch of subscriptions, you know, what do I need to do to be successful here? Let's have a think. So it's going to be subscription.iSubscription. Great. Okay. So I presume I would probably want to go through every subscription, and I would want to make sure that it has the event loop running, right? Because that's a good way to make sure that that subscription is getting the right events being updated. So prior to that, let's go back to the main, go to our run loop, and figure out, well, okay, how do we get from here all the way down to here? So let's try and write a subscription. And we might get this wrong. I'm doing this completely flying blind, but it seems to make sense to me right now. So let's go new pod subscription. .go. What does a pod subscription have? So I think I can go generate and generate I implement methods. I subscription. Maybe not. It's only one method, so it won't take me too long. So first of all, we need to have a type. So type is going to be pod subscription struct. And on that struct, we're going to have a way of reconciling when this comes along. Okay, so we're going to say func star pod subscription. We don't really need the pointer yet, but it's useful. And then we might want to change the reconcile pattern, right? Because it's quite popular to take the runtime object back out of the reconcile loop and call an update or a patch if we need to. But let's not overcook it just yet. So we've defined a reconcile. So we understand when an object comes in, we're going to do something, right? So what I could say is pod is going to be effectively something that I can cast back and forward. So in this particular example, well, why don't I take something like pod and I'll cast it and I'll do something, you know, super simple with it. So I'm just trying to think aloud what the best way of doing this would be. So if I take something like object dot pod, it's going to be like v1 pod, cast it to v1 pod, and then we're going to say format dot klog dot info f pod subscription update. So we don't really know what this is going to be just yet. We just know that this is kind of the place that we want to deal with pod logic. And we have the subscription. It talks about this is how I want to reconcile. So it feels like there's a few gaps here still. So let's figure this out. So if I go back to the main.go, how would I move the expression of this being the watcher that I want to create into the subscription handler? Well, it feels like we want to return the watch interface, right? So if I say reconcile, I can say subscribe. That subscribe is unique to the subscription, but it would return a watch.interface and an error, right? Because every subscription would need to subscribe before it could operate. So let's try that. So if we put our subscribe in, and again, this is a project that I've completely just kind of made up. So there will undoubtedly be some bits of logic we need to change later on. I based some of this on some previous work I've done, but a lot of it is completely for this video. So that's kind of exciting. Okay, so we've also hit a new thing. We now know that to subscribe, we need a client set, right? So I can't subscribe without a client set, and that will vary. The client set will vary because if it's a CRD, we need a different kind of client set. So given that it's not a CRD, and we're using the default client set here, we'll cover that later on. You can see here it returns client set, which luckily also I think there is an interface type for. interface, Kubernetes interface. I will check to see whether this client set also has an interface. But for now, let's return client set. So let's use client set. So client, that is going to be now Kubernetes.client set, I believe. And that's how we'll do the subscription. We'll put into it the client, we'll get out of it a channel or a watch interface that we can then spawn in our Go routine, our runtime. So let's go and subscribe. So we've got our client set. And in fact, is that interface going to be usable? Let's have a look. I cannot remember whether the Kubernetes interface is an interface for the client. I think it might be actually for the interface for the client set, which would be perfect, because then we can use that with CRDs as well, as long as they meet the client set. Okay, another thing that we look like we want to pass into, and I'm gonna do this now because it's good etiquette. Let's pass a context in. So context is going to be context.context. You can see already significantly the API has changed. So let's go back to the subscription and edit the API here. Context needs to be imported. Okay, cool. So we've got our context. Right. So at this point, what do? Well, we need to have a local reference to this. So watcher interface. This is what I was trying to do on the interface earlier on. So you've got watch.interface. So we could say that the p.watch interface comes down to that. So this is an interesting issue here. And this is sort of an idiosyncrasy of the language. I've seen this a few times. So you can define, that's using a pre-existing variable. The error is not defined. So I would need to define error like that, which is kind of weird. You can't have, basically you can't have one pre-existing and one being declared at the same time within the assignment, which is interesting to know. Also, the error at this point will be returning a null or nil error. Otherwise, we will be returning return p.watch interface nil. Okay, and that looks good. I might have forgotten something. I'm also defining this to be on all namespaces because for this example, I don't want to make it too complicated. And as I said, you can really overcook these things quite easily. So we've got our default client set. How do we get from A to B to C here? So if we take the run loop, sometimes if the program wants to play with you, it will let you do an inline. I'm sure I can just do it as an array. So that's now going to be in fact, we'll just call it pod watcher, pod subscription. So pod subscription is going to be a new subscription, for pod subscription, right? That pod subscription has a subscribe on it, and I'm not sure if I can just do it in an inline array. Let's try that. Is it subscription dot iSubscription like that? That should work. What's going on here? Let's have a look. Okay, so this is an interesting one. This is again like interface logic here. Okay, so subscribe as a pointer receiver. Cannot use iSubscription, doesn't implement iSubscription. Subscribe has a pointer receiver. So if we look here, it has a pointer receiver, and that will be likely here. Let's double check that. Oh, okay, as the reconcile method as a pointer receiver. Okay, fine. So just as like a note here, I don't have to remove the pointer receivers. What I can do is pass it in as I can basically dereference it, and that's just a little gotcha. I mean, I would probably tend to not use a value. I would use the pointer, but that's kind of outside the scope of this call, of this video. And if you want to learn more about the inner workings of Go, there are probably some better videos to look at. Also, this has made me realize the API is slightly clunky. Rather than passing the client interface in on the subscribe, to me it makes more sense, given we're doing the initialization, to just do it here. So let's do that. So if we take out the client set from the subscribe, we'll put the client set into the struct directly, like that, and therefore we have the capability to just invoke it from the struct, because it'll already be set, and we'll do the same with the context. And that also means that we have a much cleaner looking initialization. So we can set the client, oh, of course, client set, oops. And actually, now I think about this, I might want to make it public, accessible, might be helpful, because it's outside the package, for these two things. There we go. And the context, I will also set a new context. Let's just double check why this is giving an error. Client set has camel casing, so let's put that in there. And also let's create a general context. Now this could be a context with cancellation. That could be useful if you want to be able to control with signals. You want to control and kill your program. For now, to keep things simple, I'm just going to make a very, very basic context to do. And I will go in and rectify this a bit later on when I need to. And also it's important to make sure that we have the right package for context there. Okay, context is passed in, so that becomes context. Let's double check why it's CTX. Oops. Okay, so what do we got? We've got a basic run loop that we pass in a subscription interface, which has been initialized with our client set. Inside the subscription interface, it is using these two different methods. And in the pod implementation of the pod subscription, we've now got our client set and our context available to us, so that when we call subscribe on that interface, we can then go off and do so. So maybe we're missing one more element, which is around how do we control the run loop, or is the run loop going to have the wait group in it? So let's see how this looks and how this feels. I think we probably also want to like return on the run loop, so we'll exit on the run loop, but that we can decide later on. So let's go into the runtime. Okay, so let's figure this out. So we go for subscription. Let's have a look at our subscriptions. We've now got subscription dot subscribe, and then we've got reconcile. So let's figure out how this works. So I've got a subscribe. That subscribe returns a Y face and an error. Let's just set that up without my keyboard going crazy. I think we do need an error because we need to be able to return if there's an issue here. So if error is not equal to nil, return. That also means that in our main, we want to say if error not, let's do an assignment, error not equal to nil, panic error. Panic error, klog error, either one at this point in time, we'll get the message across. Okay, so we've now got a good feeling for the structure here. Let's jump back into runtime. So we return error on an issue. So otherwise, what do? We've got the Y face. So we could loop through them all. I think that there needs to be a correlation between the I keep calling it Y face, but the watcher interface and the subscription. So let's think about how this would look. Would we go through each time and say go, func, and then we'd run an inline go function that would run once, and then we could say yface dot, we could then do a for. The only thing about doing this is we could introduce issues with routines going rogue, and also it could cause issues with synchronicity and shutdown. Let's do it as a naive implementation, and then we'll have a look at the pitfalls in a moment. So we then get the message back. That message is assignment, and that message is then on the current yface.results channel. Now, interestingly, we're here, so we then also have subscription dot reconcile message dot object message dot type, right? Which is what we wanted all along. It was the ability to pass the reconciliation into a single place. And this is how you can build operators that to the user seem really simple, right? It's just a single reconcile loop, and you can pass the event type in. And under the hood, it's doing a bunch of stuff. So let's have a think about this and have a look. I mean, I've not run the code for what feels like a decade, but we're getting there. So we have now our subscription. Let's think, is this a good way of doing it? And also, what's going to happen? So that's going to loop once. It's going to run this routine, and the main.go is going to exit. So how would this be different if we used a wait group, right? So var wait group, sync.waitGroup. So I guess what we could do with the wait group is you would have a wait group for each gofunc, right? So you would add a wait group.add, right? And then at the end of this, you could have a select on the case. In that case would be yface.message yface.stop. In fact, I'll have to check that. I think the purpose of that interface, the purpose of that method is to call stop. We might want an additional signal handler. So let me just put this in a to-do. Do we want a way of escaping from our Go routines? So that could be that we could pass a signal handler into them. So at the moment, I'm adding on the wait group, and then at the bottom, which in this case never gets called, we could do a done, a wait, yes, a done, and then here we could call our dot wait. So theoretically now, this will never exit because the wait group will add, it will then wait for this done, and we'll see what happens. It should just, the main thread will sit here. The main routine will sit here. So I've not run this for a long time. Let's see just where we get to. I'm curious to see how much this does and doesn't work. Well, firstly, we've got an error. So we're missing a library. That's fine. Let's grab that library. So if I just go grab it like before. Okay, I've got that library. I'm going to go back to try and run this again. Let's debug. Okay, so far so good. Built config from flag. So what happened? Let's have a look at this. I think I've probably introduced an issue in my logic. I think maybe having the wait group inside of the function was the mistake. I will trace it. Let's have a look. Like, we don't always get these things right first time. And I'm sure watching the video, I've probably made a pretty obvious mistake. Let's have a look. So let's go through. So we go through our subscriptions. Got our first subscription. We get back our channel, create a new function. Right, okay. So the function, right, so the function didn't look like it executed. Am I doing something really obviously wrong? Let's try again. Stop and return. Let's just check to see that we hit inside of the gofunc, like simple stuff. Okay, let's have a look. Am I hitting inside of this for loop? Okay. And again, what we're trying to do, it doesn't look like it's hanging at some point, so let's try and figure out where it's hanging. So let's have a look. Now what I'm looking at on my other screen is I have a bunch of notes that I took a long time ago around concurrency. Yeah, I mean, I don't think I'm doing anything particularly magical here. I'm just calling that function directly. Let's try again. I wonder if I missed it in my breakpoints. Okay, so let's get this going. So stop. Start again. Oh, here we go. I might have had multiple attachments. Okay, when in doubt, sync wait group. And we will make sure that I've done the right thing. Add, wait, and we defer the done. The done shouldn't get called in my case. Yeah, you can see here we've got this in the top. Yeah, go func. Oh, it's outside of the func. Okay. That should still be okay. We're not returning at this point. Tell you what I'll do is, I think we'll start simply here, and we can have a manual wait. So we can create a channel for each one of these. So when in doubt, try and stick with what you know. So we've now got these functions, and I am going to check to see that this is actually hitting it at all. Let's just put a quick for in, and we'll say select channel. In case we'll put a cancellation context or completion context, you can say we can make a channel. I'm thinking that we could do a channel type of int, and then if it's complete, in fact, message. And if it's complete, we could just do a little continue, a little break out of this. Okay, so that's really basic, but that will keep us inside the main loop. Yeah, that does become unreachable code. And we'll get this going, and then we'll figure out what mistakes I made in a moment. So let's have a quick look. And this is never getting, this complete is never actually getting called at this moment. The idea is you call it inside of your code. And what we could do is we could make it a little bit more sophisticated, and we could have it a completion. So we could say something along the lines of is complete or has finished. Maybe that's another way of doing it. Let's just put is complete. And then we can return a Boolean channel. And we can say is complete. And for now, until we actually set that, I can put that there. I can return false. In fact, we'll return a new channel. So we will return the initialization channel. So we can say completion channel, chan bool. And we start, that starts as false. Let's return b.chan our completion. Okay, and that can get set in the completion. It's going to be make chan bool. Okay, so that's our completion. And then in the runtime, we can say, we can remove this, and then we can say for and this point in time, we can just say, well, look, if there's anything that's not complete, we won't complete. So we'll say for subscriptions, and very similar manner to the loop above, actually. We can say then, for let's say select subscription. We will select a case complete, and that will be subscription dot. It helps if you put the index first. Dot is complete. Return break. So this is kind of a simple example. Yeah, I mean, this is going to just loop in a dumb way, and we'll figure out. And I promise, by the time the video releases, I will sort this out. But this will sort us for now. So I'm not really sure what I did wrong with that working group, that wait group. So we'll look in a moment. So great, we're at a point now where hopefully our code will run. Let's just give it a go. Shouldn't be any unreachable code. Seeing a little error here. So it's complete. That goes into subscription.isComplete. That returns a channel. Oh, I'm sorry. The channel itself. Pop in here. That channel is returning a channel. And what I want to do with that is make that channel return. And that should sort this out. Let's just see what my error is before I go debugging too much. Let's figure out the issue. Unexpected new line. Oh, it's a simple syntax issue. This is always the way. Okay, so there we go. We've got some basic stuff working. So now we can see we've got this pod subscription updater. So at this point, you can write controller logic, right? So we could have a bunch of stuff in the reconciliation loop that we could use ubiquitously throughout the project. To make it a little bit more operator style, let's do something, right? Let's make sure that all these things are annotated, and if the annotation drops or the annotation changes, we should be able to do something. Typically, you might see when you're using something like Operator SDK, folks will be drawn to having a main reconcile loop, and then they will create methods on the controller. You can do that, or you could create a separate package. Because the logic is so simple, and I'm trying to help explain how you can write your own operators, I'm going to keep it pretty straightforward. So let's just do a basic switch, and let's switch on the event. And that event has a bunch of different cases, right? You've got watch.eventType, added, modified, deleted, bookmark error. So let's do added, modified, deleted, and then we can come back. So case added, so we can go watch.event added, case watch.deleted, case watch.modified. Great. So we've got our three types, and you can see already we can start to think about plumbing together some of the behavior. So at this point in time, we're going to soon come up against a new challenge, which is we want to modify or change an object. So before we do that, let's have a look at just making sure we understand what are the actual events we're getting in. So pod subscription, event type for, okay, so let's go back to this. We're going to rerun it. And we're just going to check out and see what do we actually get under the hood here. So give me one moment. Okay, so added. So this is because we're seeing these added to the event stream. So this could be cool to do something with these pods, right? So how do we do something with these pods? Well, let's take a look. So I'm going to say update. I'm going to call it updated pod. And this is where we use the piece of config or the piece of code I was talking about earlier, where in our CRD generation for operated SDK, we get deep copy written for us. We also get this in the default library. It's not yet native to Golang, but deep copy will copy over effectively the contents of each resource type. And that's actually why you have to have it written for each resource, and why these GoGen helpers are really useful. It's not like Java where we natively are able to copy the entire object. So we've got that updated pod. Now what does that mean? Well, updated pod is necessary because we want to make a copy of this pod, do something with it, and then write that back to the case API. So let's say updated pod dot annotations. We're going to say, well, before we do that, right, I guess we need to check, but it is on an added event, so it's likely that it won't have it, but still it helps to be thorough, so we'll call it type SRE. So let's just go ahead and check and say if pod.annotations type. Again, this is going to be probably a map, right? So we're going to have to do a little check, right? So it's a map. Okay, so I always forget the order of this. I think it's val. Okay. We say if. Oops. We say if not okay. Okay. I'm just going to double check, and there's no shame in double checking. Was it Golang map check key would be my typical Stack Overflow. Yeah, so val comes first, and then it's okay. We don't need the value. We're going to update it. So if if type doesn't exist as an annotation, we're going to create a new deep copy of that pod. We're going to set that annotation, and this is the most important part, is the update the pod. How do we do that? Well, we have the client set from earlier, so that is where we call receiver p.clientset.corby1.pods. Now we're going to take our pod .namespace .update p.context. What else do we need? We need the pod itself, so this is the updated pod, and then we also need the update options. Oops. Update options. So that's going to be, I think, a meta v1 update option. Update options, cool. So let's see what happens. Let's go update error. So you got, that actually returns to you the new pod error. And if there's an error, we don't really have a way of handling the errors at the moment, so we're just going to do a local print. I'll call it error. And I'll just put a little breakpoint so we can walk through this together and see how this works. Okay, so we're now looking at this pod resource. We are actively doing something, right? So we're now checking to see, does the pod have a label? Precisely, does it have an annotation? If there's not an annotation, we're checking that, and we're then writing, doing a deep copy and writing to a new, an update to that pod. So let's go and do that ourselves. Write, update, annotation. Okay, and we can get rid of this. We don't really need this right now. We can just pull this down a bit. So let's have a look. Let's see what happens. So let's kill this. What might be quite nice to see is if I bring this up on my second screen with canines, we could look at the pods. So let's run this again. Okay, so we can see now we've got an event type added. The pod name is object meta name cube controller manager kind control plane. So that's this pod right here. Let's see what happens. So let's do an update. Step over. So I didn't see an error. Let's have a look. And now we can see we have type SRE. Yay, how cool. And let's go through, and again, what I would also expect to see is that this will run through successfully for all of our remaining pods. So I'm just going to undo the breakpoint, continue. Okay, so we've got a bunch of stuff here that's worked. That's great. I've got a panic here. I'm not really sure why. Let's have a look. So it looks like if we go back, it's coming from the possibly decoding one of the pods. I'm going to run it again. This is totally normal to get these kind of issues when you're doing a bunch of this sort of complex logic. I can see actually that it's not added onto this particular pod for KindNet. etcd it has, so let's have a look and figure out what we can deduce from this. And again, this logic probably wouldn't get called normally again because we would have checked this. It could actually be my type checking is wrong. It could be annotations is nil. Okay, so OK is false. So this is a pod that's missing it. So this pod is local path provisioner. Okay, great. Let's just keep going until we hit that error again. Okay, so that was, I think, on local path provisioner. So you can see, if you look at the call stack, you've got inside the reconcile, there, the update pod type equals SRE. This could be because the map isn't initialized. I'm not sure. Let's check. So, you know, it won't hurt. You know, in this example, there aren't any other annotations set. So I could make a new map. But really the favorable thing to do would be to find out the exact error. So I'm going to try that again and just see whether that might solve the issue. Because you don't want to just start initializing on something that's not been updated. So that's done. So that fixed it. So that was the error. And you can see now we've got a bunch of modified events, because that's kind of the next part of this is you are now modifying the pod. So what about handling this event if it's type SRE? So we'll do one more example, right? So now that we have the first step through the reconcile, this is the second step, and this is where I think that sometimes folks get confused with writing controllers and then going on to make those controllers more complex operators, in that it can become overwhelming understanding the reconciliation pattern. So what would happen is your pod goes through in the added event, you modify it with an update, it goes through again through the watch stream on the modified event. And then in the watch stream here, I can say, okay, well, you know, in fact, let's stop this. We can do one more thing. We'll print something interesting, perhaps. We can say, excuse me, if pod.annotations type is equal to SRE. And again, I might be opening myself for a little bit of danger here because I need to completely make sure that's initialized. If the type is equal to SRE, we could say something along the lines of, hey, it's worked, right? So klog dot, in fact, we can say info, this could be some custom behavior beyond just a CRD. And if you think about it, how would I test this? Because these pods are all set now. I wouldn't actually expect this to fire because there are no more modified events going to be coming through. So what you could do to test this modified loop is to simply delete the pod, because when it recreates, it'll go through the add, and then so for example, if I do a delete on the DNS pod, it will delete the DNS pod, and then it will recreate it. So interestingly, let's have a look. We've got an error on one of them, which is to do with the kind controller manager. So metadata, so Kubernetes config mirror forbidden. You may not remove or update the mirror pod annotation, and that's actually interesting and useful to know. So we go down to here. You can see that it has some system level annotation set. One of the things I did here was I reinitialized the map. So probably what would be a slightly better way of doing this would be to check to see if the map was initialized first at all. what we can do is, in fact, this is not a pointer. This is just a value. What we could do is we can check to see if there's anything in the annotations list already. We can do a len on it. We could also do a direct check. But yeah, that's again a danger area. And that, just to be clear, that error is because I tried to purge the annotations by doing a make on the assumption that it's a new pod, which isn't always the case. So it definitely takes your knowledge to the next level when you have to start thinking about the way these objects are working in memory. And I hope that this is useful actually, because it's not always straightforward, and I think that sometimes delving into it like this can be really great. So if you see here, I'm getting that this could be some custom behavior, because you see they've got two modified events occurring. The second of which, the first one was the controller manager, which was refusing my update, and the second one is this type SRE that's been triggered in the modified. So this is the initial bare bones of how you would write from the ground up with no controller runtime, a bare bones Kubernetes operator. Now, I preface operator by saying there's a lot more to an operator versus a controller, right? You know, a controller is just looking at creating, updating, deleting. We've created some very simple operator-esque logic, right? On when a pod is created, set some annotation, and if that annotation is set, do something else. And effectively, it's creating a kind of secondary layer on top of that of more complex behaviors under certain conditions. You know, whether that's rolling out an etcd cluster, whether that's managing Prometheus and its resources. This is the kind of way you do it. Now, I would like to close this by saying that, you know, effectively, I don't expect folks to write operators from the ground up, right? I don't expect you to write controllers from the ground up, but I would recommend to anybody to give it a go, just in a lab sense, because as you can see today, you learn so much about how to interact with the Kubernetes API, how to interact with the Golang API, and how to just learn about the asynchronicity and some of the behaviors around it. I hope this has been a useful video. It's quite a long one. Please like and subscribe if you'd like to see more. I'm going to continue this series, and I might come and revisit this again to look at adding observability, telemetry, and having CRDs in the mix. Because I used a very simple built-in client set, but obviously to take it to the next level, we want to think about bringing in custom resources, and that we'll have to start looking at types.go, looking at API versioning, and so I'm excited to take that next step. And if you want to talk about this, you can always reach me on Twitter. My handle is below. Thank you so much again. Cheers.